This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. All right, we're going to solve this trig equation. 3 cosine alpha plus square root of 12 equals 5 cosine alpha plus radical 3. And we're finding all angles in the interval negative 360 degrees to 360 degrees. Okay. So basically we're trying to solve for alpha, okay? So the first thing we need to do is solve for cosine alpha. And you see there's cosine alpha in more than one spot, right? So in other words, here's a cosine alpha and here's a cosine alpha. That's just like an x. What would you do to get the x's on the same side of the equation, for instance? Okay, well, if it was, just before doing this one, what if this was 3x plus 2, let's say, equals 5x plus 1, or something like that? You would get the variables on one side and constants on the other. So I like to put the positive number in front of the variable, so I might just subtract 3x from both sides. All right, so that would be a strategy, right? So that you'd have 2x on the right-hand side of the equation, and then I would also subtract 1 from both sides so that I have a constant on the left. We're going to do the same thing here. Let's look up here. But I really have 3 cosine alpha and I really have 5 cosine alpha on the right-hand side. So I'm going to first get rid of this here so it's real clear. I'm going to subtract, 3 cosine alpha from both sides. So this means I would have 2 cosine alpha on the right-hand side of the equation. And so I'm going to also subtract radical 3. So I only have I'm isolating the cosine alpha this way, minus radical 3. Now what do I have on the left-hand side? Be very careful here. The 3 cosine alpha minus 3 cosine alpha, well, that's 0. But I've got square root of 12, minus the square root of 3. And that is not the square root of 9. First thing, I want to make sure you realize you can't just subtract the 12 and 3. But I can simplify this square root of 12. I'm going to do that over on the right here. Square root of 12 is the same thing as the square root of 4 times the square root of 3. So that's going to be 2 square roots of 3. So I'm going to simplify this to 2 square roots of 3. And remember what this is? This is the same as 1 square roots of 3. You do not have to put the 1 in front of it, but I'm doing it so that you can see that my next step will be to subtract the coefficients, because now these are like terms, right? They're both square roots of 3. So that's 1 square roots of 3, or just plain old square roots of 3. So I have square root of 3 equals 2 cosine of alpha. All right, so I've got the variable part on one side, but I need to get rid of this coefficient of 2. So let's divide both sides by 2. So that I have square root of 3 over 2 equals the cosine of alpha. So what I have is that the cosine of alpha is square root of 3 over 2. And I am looking for solutions in between negative 360 and 360. So now let's work on that part. All right, so where is the cosine positive? That would be in quadrant 1 and 4. So first let's just figure out where it is between 0 and 360. Where is the cosine of alpha equal to square root of 3 over 2? Let's see, it looks like it'd be about here and here. So that's, right, square root of 3 over 2, where that would be 1. And we're doing this in degrees, right? This would be negative 1. So this first one, the positive angle, would be 30 degrees. So one possibility is I've got 30 degrees. Okay. Now I'm going also negative all the way up to negative 360, so you might notice that this is negative 30 degrees. That's also going to be in there. Okay. But I can also end in the same spot right here by going in positive direction, right? And so that is 330 degrees. Okay. I could also, to get this one up here, go in the negative direction all the way up to here, running out of room, right? And what would that be? That's negative 330 degrees. Now, not everybody can see that easily, but those are the four solutions that are in between negative 360 degrees and 360 degrees. So here's another way of thinking about it. Just get your two angles that are positive, right? So let's say you've got 30 degrees and 330 degrees. Now you know coterminal angles, you can get any coterminal angles by adding 360 or subtracting 360. Well, if you added 360 to either of these, you're over 360, right? You're only allowed to go up to 360. But if you subtract 360, so in other words, if you subtract 360 from each of these, oops, got a little crazy with my zeros, you're going to get a negative angle that's still less than 360. So this, for instance, is your negative 330 degrees. And this is your negative 30 degrees. So your final answer is just same answers, thought about it a little bit differently. And if you'd like, you could do this. You could put plus or minus 30 degrees instead of writing each of them. Or you could write your answer like this. You could do negative 330 degrees, and negative 30 degrees, 30 degrees, and 330 degrees. In other words, basically you're showing there four solutions. This is if you happen to write from the smallest angle to the largest angle, but you don't have to write it in any particular order. These are just the full solutions. Now to check your answer, you would have to check four different solutions in the original. Let's just check one of them. So let's check to see if when I plug in 330 degrees for alpha, it's true. All right, so the way I like to check is I just underline the whole thing. And I'm going to plug in 330 degrees for alpha and simplify the left-hand side of the equation. Now, square root of 12, we already figured out was 2 square roots of 3, so how about that? Now, where's the cosine of 330 degrees? Well, either you memorize it or you figure out some way. I do it like this. I say, well, that's square root of 3, negative 1, 2. It's going to be square root of 3 over 2. So when you plug in the cosine of square root of 330 degrees, you should get square root of 3 over 2. And you're adding 2 square roots of 3. So I have 3 square roots of 3 over 2 plus 2 square roots of 3 over, right? But I'm going to get a common denominator here by multiplying the top and bottom by 2 over 2 so that I could write that as 4 square roots of 3 over 2 to get a common denominator. And then I could add the numerators, which are now like terms. So I got 7 square roots of 3 over 2. That's what the left side simplifies to. Now let's see what the right-hand side simplifies to. Again, you're plugging in 330 degrees for alpha. And the cosine of 330 degrees, we figured, was the square root of 3 over 2. And we're adding that to square root of 3, right? So I have 5 square roots of 3 over 2 plus, and I see I'm going to have to get a common denominator here, so I'm going to multiply this by 2 over 2, which gives you 2 square roots of 3 over 2. And then if I add the numerator, since I have a common denominator, I get 7 root 3 over 2. Same number on both sides, checks. So the only way to tell that all four of those are solutions, you would have to go through this process on the other three as well. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.